Let's take a look at the arm. As you can see, ID 1 is at the shoulder, ID 2 is the elbow, ID 3 is the wrist, and ID 4 is the hand. And I've taken a whole bunch of close-up photos of the arm so that it'll be easier for you to identify what bioloid frame goes where. So let's take a look at the other photos right now. You can see that I've marked the ID on all the photos, and I've also marked the corresponding bioloid frame number in all the photos as well. This is pretty self-explanatory. I mean, for example, to connect the F3 and the F1, I used 4 nuts and bolts. For the most part, I used 4 nuts and bolts to connect all the motors and the bioloid frames. And the longer bolts that I reference here, those are the longer bolts that I recommend that you purchase from my ReadMe file on the GitHub page. And please feel free to pause this video anytime and go back and stop the video to take a closer look at how everything is connected if it's going too fast for you. Let's go over the useful reference material, links. And there's a lot of really important stuff in here that I just want to go briefly over with you. So let's take a look at the first one. This is, the site here is called pinout.xyz. So the most important thing that I wanted to show you in this one is up here in this toolbar you have UART. So you have basically, if you click on the home page here, it'll tell you about all the pins, the GPIOs, general purpose input output pins. But if you click on UART, you'll notice that BCM14 and BCM15 are dedicated to UART. And that's what we're using in our project. We're using UART, which is an asynchronous serial communication. And so you'll be connecting the breadboard to the BCM14, which is physical pin 8, and BCM15, which is physical pin 10. And so you'll also be using BCM18. And that's what sends the signal to the 74 LS241 IC, the octal buffer. But there's a lot of really good information here if you get the chance to peruse it. You should be familiar with the layout of the Raspberry Pi. For example, there's 2 5-volt power pins. These are dedicated 5 volts. So the other ones are general purpose, which means they can send out 3.3 volts, or they can receive an input, and there's a whole bunch of stuff you can do with them. If you click up here, you'll see how it highlights different ones based on needs, right? So I2C, all right, but the one we're interested in is in UART. So you may want to check this out and just read through it briefly, quickly. Then we'll take a look at this guy. So this is the first website that I found that had some really good information on how the instruction packets were created, and how the Raspberry Pi, how the breadboard was wired up. So I don't know if you remember, but I mentioned before that when I showed you the diagram in a previous video of how to wire up the breadboard, you saw that it was really nicely done graphically, right? But a lot of these sites will actually give you a text-based instruction on how to wire it up, which is really confusing and much more difficult to follow. The other thing is, they did a pretty good job here. They do have the Octal tri-state buffer here, the 74 LS241, and they got pretty close. But the problem with this is that it doesn't give you enough detail, and that's what I was trying to do with my project, is provide enough detail so you could complete it from start to finish. Another thing is, when I first took a look at this stuff, I was trying to figure out what was needed, what wasn't, and then I realized that this blog post was done probably 10 years ago, and so a lot of this stuff is no longer relevant. And I was using TTY AMA 0 as my serial port, and that was a problem because I actually needed TTY S0. So that kind of threw me for a loop. That took me a couple of days to try to resolve and figure out, until I found out, that I needed to use the other one. And then here, for example, they have errors as well. They're saying execute an action 5. Well, if you look at the instruction packet here, 5 does not correspond to execute an action. 5 is the length. So the ID is always first, the length is always second, the instruction is always third, and then you got the parameters. You got 1, 2, 3 parameters. Now remember, I was telling you that 3 plus 2 would give you 5, right? So you want to add up the number of parameters and then add that to 2, and then you get the length. That's what you would use. So, but it was good, it was good enough information that it was helpful to me, and it pointed me in the right direction. Now, these are the official Robotis e-manuals. So when I first started, I was working off of these, okay? And these are the old manuals. So I know they say site renewal notice, blah, 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 this is deprecated, this is going to be removed. But I started working with these first, okay? And so I learned everything from here. I try to basically to memorize everything in here. And like you still have 3 here for the ID and the ID of Dynamixel, but these are old documents. So you can go back and read them. I mean, I read them all, and I thought it was very helpful because there's some stuff that's covered in the older manuals that's not covered in the newer manuals. And so it gives you a good all-around view of the technology. So this one right here, as you can see, this one is e-manual, robotis.com, docs, blah, 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 protocol 1. And so the protocol 1 gives you the sample packets. So if you see here, we already went over this before, the instruction packet, and we already went over all this in a previous video. Okay, but there's some really useful information here. Remember, I was telling you about the 03 being the write, So this is where you would find that, you know, you could do a sync write, you could do a reg write, and then an action. So this is very, very important stuff. And then you know, they kind of give you the instruction about the checksum as well here. But I don't know, this to me isn't as clear as the way I presented it in a previous video. The status packet, you know, eventually you'll get to the point where you want to learn about the status packet, because that's a very powerful feature where you ask the servo to give you information like, you know, the voltage, the temperature, the position, stuff like that. And then all this other stuff here. So this is very, very important. Let's take a look at this other one. So again, this is I would say this is more like the manual. So I would consider this the AX-12A manual. Okay. The other one is more, you know, they consider it a protocol 1 document. And this one, they just refer to this thing as like the control table. But it's got way more than that. So if you look at the control table here, we already went over this. You know, you have 3, you have ID. When it says EEPROM, that means it's permanent. Okay, that means that when you turn power off, these settings stay the same unless you change them, of course. But this is versus RAM. Okay, RAM is only in memory while power is being applied to the servo. Once power is taken off the servo, then all these settings will be lost and will be reset to the initial value. So, for example, a big one here would be goal position. Okay, we use a ton of that in our project. And if you look at goal position, I just want to point something out to you. So here, you start at 0, and you go to 300 degrees in a, let's say in a counterclockwise direction. So the goal position here is 1023. So you'll notice, for example, you know, if you want to go to position, like if you want to go in the middle, it has 150 degrees. It's also 512 decimal and 200 hex. So you would use actually 200 hex. And you don't just write 200 on the instruction packet. You have to take 00 and then, I'm sorry, you do 02 and then you do 00 in front of that. And I'll go over that in more detail when we review the actual code in GitHub for the project. Again, this is the old, you know, quote-unquote user manual. You know, I printed all this stuff out onto PDF files, and I just marked it all up. You know, I used the tools on the PDF writer for adding comments and stuff like that, and it really helped me to better understand it. You also have, you know, you also have the diagram here for the position, and then just a ton of other stuff and more examples. They in some of these documents, they'll give you way more examples. So this is another site that I really like. If you're new to the Raspberry Pi, you'll definitely want to read this. Read it cover to cover. And this guy talks about electricity, voltages and currents and stuff like that, and tells you everything about the pins, and then gives you instructions on how not to destroy your Raspberry Pi. So very, very helpful stuff. And then finally, this is if you take a look at this, Robotics Images Production AX-12 English. Okay, this is an older manual as well, and it's in PDF format. And this one has a lot of information about the AX-12, but a lot of this stuff also applies to the AX-12A. So I also marked this guy up. I read it cover to cover and marked it up. And as you can see here, for example, this is important. So the ground pin is the pin closest to the middle part of the servo. And I make a reference to that in one of my documentations. And then you have the power, which is VDD. And then you have the data pin, which is the last one. So you'll notice here, ground is on the other side, VDD and data. So when you connect, these connectors are keyed, so they can only go in one way. But it's good to know where things are, because when you hook it up to power, you'll wanna connect your power to the VDD if you're using an external power supply like the bench power supply that I have, or if you're using a battery, you'll want to connect it directly to the VDD.